Okay. Now we're going to take a look at these proportions, but in the context of these similar triangles, or similar polygons, I should say. All right, so similar figures. Similar figures have the same shape, but not necessarily the same size. The symbol is this like tilde symbol. Similar polygons. Two polygons with corresponding angles congruent and lengths of their corresponding sides are proportional. So I could draw, here's triangle ABC, and they're all 60 degrees. Here's triangle DEF, so they're not the same size, but the angles are the same. So I would say here triangle ABC is similar to triangle DEF. All right, the scale factor is the ratio of the corresponding side measurements of two similar figures. So let's look at these examples here. So if DEFG is similar to HJKL, what are the pairs of congruent angles in the extended proportion for the ratios of the lengths of the corresponding sides? All right, just like we did back in chapter 4 when we did congruent figures, we lined up the letters. I'm going to do the same thing here. So angle D is going to be congruent to angle H. Angle E is going to be congruent to angle J. Angle F is going to be congruent to angle K. Angle G is going to be congruent to angle L. And then when I create my ratios for the lengths of the corresponding side, when I create that extended proportion there, again, I'm going to line up everything. I'm talking about length, so I don't have any notation on top. So DE over HJ is going to be equal to EF over JK. So I'm just lining up the letters. Is going to be equal to FG over KL is going to be equal to DG over HL. Okay? Down here it asks, are they similar? If I look at all the angles are similar. Now if I want to check the sides, so it's a rectangle, this is the small side here, this is the small side here. So it's 10 over 15 equal to the two larger sides, so 15 over 20. Well, this can be reduced by 5, and I end up with 2 over 3. This can be reduced by 5, and I end up with 3 over 4. So these are not equal, so no, not similar, because the sides are not proportional. Over here, two 90-degree angles, two pairs of angles with these markings here, and a pair of angles with those markings. So the angles are all good. Let me line up the sides. Here's the small one, here's the small one. Here's the larger side, here's the larger side. No other sides, no other numbers for me to worry about. They all are the same combination of these numbers. 12 divided by 6 is 2. 8 divided by 18 is 2. So yes, these are similar. And if I wrote it out, I don't have a symbol for a pentagon, so I could just say A, B, C, D, E is similar. And I want to line up the letters. So A lines up with this S because it's between the short and the long, and it's on that angle there. B goes back on the straight edge, so that's going in that direction. So R, V, so I'm just going around this way now. U, T. The T is the point of both of those. All right. This one, it tells me that these two trapezoids are similar. So the big trapezoid is similar to this small one right here. And I want to find the missing sides in the small one. So 6 is from the small one over the 9 from the bigger one is equal to the x from the small one over, we'll use the 7.5 from the big one. So if I cross multiply here, I get 9x is equal to 45. Divide by 9x is equal to 5. We'll do the same thing with the y. So I can still use these pairs of sides again. So 6 over 9 is equal to y over the 5. 9y is equal to 30. Y is equal to 30 divided by 9, or 10/3. All right, in this example, we're scaling things up here, okay? So Mr. Morley is making a rectangular poster of math jokes. The design, so he has it on paper, it's only 6 by 10 inches. But he can blow it up to 3 by 4. But these are in feet, so 3 feet. So 3 times 12 is the same thing as 36. 4 times 12 is 48. So that's what he can blow it up to. So those are in inches now. So the 6-inch side right here matches up with this 36-inch side. So the 6, to go from 6 to 36, I'd have to multiply it by 6. If I multiply 10 by 6, I'm going to end up with 60. So that's too much. Let's look at the other dimension. So to get 10 to 48, I just have to multiply it by 4.8. If I multiply 6 by 4.8, I get 28.8. So not as big as my 36, but yet it'll still fit inside there, okay? So again, I've got that 6 times that 4.8, which gives me the 28.8. I've got the 10 times the 4.8, which gives me the 48. So I could be 28.8 inches by 48 inches. 28, if I divide that by 12, I'd have 2.4 feet by 48, 4 feet. I could also set this up using a proportion. So I could have done 48 over 10 is going to be equal to whatever it is in the new poster divided over whatever it was in the old poster. So that dimension, I know that the 10 is automatically going to 48 because I'm using that scale factor. But here, since I don't know what the 6 is, if I cross multiplied here, I'd get 10x is equal to 288. Again, divide both sides by 10, I get 28.8, which is the same number I had before. So that's another way you could do it. Probably the way I did it in blue is the way that you would just kind of think to do it. All right, a scale drawing is a drawing with lengths that are proportional to their corresponding actual lengths. Scale, so the scale is the ratio that compares each length in the scale drawing to the actual length. So it says, if the scale in the above drawing is 1 centimeter to 5 feet, what are the dimensions of bedroom 1? So we have 2 by 5.5. So I could do 1 centimeter over 5 feet is equal to 2 centimeters over what I don't know. So I'd get 10 feet. And then I could do 1 centimeter over 5 feet is equal to 2.5 over what I don't know. So y is equal to 12.5 feet. So the dimensions of the room would be 10 feet by 12.5 feet. Okay? So I'm going to look at 2 homework problems with you. I'm going to look at 22 and 38. All right, so for 22, this is just like the one that we just looked at with the poster and Mr. Morley. We have a mural design, 9 high, 16 wide. And we want to blow it up to be 24 wide, 14 high. So 14 is in feet, so in inches, that's 168 inches. 24 is in feet, so in inches, I got 288 inches. To get from 9 to 168, I'd have to multiply by 8.67. To get from 16 to 288, I'd have to multiply by 18. This one's too big. If I multiply the 16 by that number, I'm going to get a bigger number than 288, so this is what I'm going to use. So the 16 by 18 is going to be 288. The 9 by the 18, so I'm using that scale factor right there, is 162. So I've got 288 inches by 162 inches. If I divide those by 12, this is 24 feet by 162 inches. So 162 divided by 12 ends up being 13.5 feet. So you can leave it like that. That's also 13 feet 6 inches. Okay? All right, and then I'm also going to look at 38 with you. So for 38, we want to figure out x's, and then we want to give the scale factor of the polygons. So for 38, I would, again, look at the letters up here. So NK lines up with PR. So I've got 3x minus 2 over x plus 4. And then I'm just going to pick the whole numbers instead of the decimals. So this GM lines up with VT, so the 3. I'd cross multiply 4x plus 16 equals 9x minus 6. Subtract 4, add 6. X ends up being 4.4. It asks for the scale factors, so I always just go the first to the second. So the scale factor is just 4 to 3. You could also write it as 4 over 3. Okay? All right, that's that one.